Okay, as we look at example 2, we got the integral of e dx all over the square root of e to the 2x minus 1. And so you're probably looking at the arc secant pattern because you have an equation minus a constant. And so as you do this problem, you just want to go ahead and set it up so that you have your u squared and your a squared. So let's go ahead and go to the whiteboard here. So on my whiteboard, it says I got the integral, and then I've got dx, and that's going to be all over the square root of. I've got e to the 2x minus 1. So I'm going to let u squared equal e to the 2x. So u, when I take the square root of both sides, so u is going to equal just e to the x. So my a squared equals 1. So when I take the square root of both sides, a is just going to equal 1. Now when I take the derivative of e to the x, so the derivative of e to the x is just going to be e to the x. So remember, your integral of the arc secant matches up with du, and that's going to be all over u times the square root of u squared minus a squared. And that equals, when you get it to match up, that equals 1 over a arc secant of u over a, and that's the absolute value of u over a, plus c. So when I reset this up, I'm going to put my e to the x in my numerator. But since I need that u right here, that's going to be all over e to the x. And then that's still times the square root of u. So I've still got my e to the 2x minus 1. And so that matches up exactly now. So I've got 1 over 1, because a is 1, times the arc secant. Bring that back up again. So times the arc secant of u, which would be e to the x all over 1 plus c. So when I solve that, I get arc secant of e to the x, absolute value of that, plus c. And that would be my answer.